Good afternoon, class, and welcome to today's recording on navigation and surveying. I am not here today, obviously, so please pick up a copy of the notes and project at the front table, and when you're ready, we will begin. Please have your calculator and pencil ready. Please click pause right now, and then click play when you're ready for me to resume. Example 1. The ship leaves a port at noon and heads due west at 20 knots. Let's take a look at what's going on here. This is a surveying problem. So in these problems, first the word problem. So figure out where you start from. And you start from P, which is the port. And I noticed I have a compass bearing of north, east, south, and west. And you're going west. I can't emphasize that enough. You're going west, okay? And you're going at 20 knots. Well, what are knots? Well, knots are units that measure miles per hour, but on the water, pretty much, right? 1 knot is equivalent to 1 nautical mile per hour, and I kind of gave that to you there. Notice the cursor is blinking, so I'm moving the cursor away so it does not distract you. Where are we getting this 40 miles from? You see this 40 miles from here? Well, take a look. You go from 2 hours because you start at noon and you go all the way until 2 p.m. That's 2 hours. So you do 20 knots times 2, and that's 40 miles. Once you do that, I think we're ready to move on. If you need to click pause, this is a good time to do that. Because now what we're doing is it's 2 p.m. And to avoid a storm, we're going to change our course to 306 degrees. But we're also picking up the pace to 25 knots. Okay, so let's take a look at what's happening to our picture. Here's where we started from. We're at the port. We went 40 miles due west, and now we're here at T. I call it T. Here's the north bearing. And this time we're going 306 degrees. You always measure an angle from the north bearing when you're doing navigation problems. And that's the path. So that's the 306 degrees. Okay? But where's this 36 coming from? Well, that's 270 plus 36, 360 degrees in a circle. So that 36 is 270 plus 36, which is 306, okay? The 54 is 360 minus the 54, which is also 306 degrees. 25 miles here. Let's talk about that. You start at 2 p.m., you go until 3 p.m. That's 25 knots per hour times, 25 knots rather, times 1 hour, and that's 25 miles. When you're ready, please move on. Again, if you need to put me on pause, no big deal. It's completely understandable. Now let's take a look at the final piece of this problem. And your picture should look something like this. And I'm actually going to erase this 3 up. I can't erase the 306. And I want you to ask the question, okay, what's the distance? And to prevent confusion, I'm just going to cross out this N that was originally meant to be north. But this little T is what we're trying to figure out. I want to figure out this green segment, which is from S to P. To figure out this green segment, we need to use the law of cosines. To use the law of cosines, let's do the following. We have side, angle, side. And if you don't believe me, let's circle what we know. And I'm just going to... So to figure out T, let's use the law of cosines. And we know the 25 miles here. We also know the 40 miles. So now we also know this angle is 54 and 90 degrees. Add them up, you get 144 degrees. So the law of sine says t squared equals 25 squared plus 40 squared minus 2 times 25 times 40 cosine of 144 degrees. That comes out to be t equals 62 miles. Please take a moment and try this. While you're trying this calculation, I'm just trying to figure out what... I'm having problems with the smartboard. I don't know if you've noticed. I'm sure you're all looking at me like, yeah, we've noticed, Mr. Harrison. This hand figure will not go away, so I can't do my drawings, which is bothering me a lot here because it's not... This isn't... oh, that's not what I want either. Undo, okay. Hopefully you guys have done this calculation. Hopefully everybody had a good weekend. What'd you do over the weekend? Cody, what'd you do over the weekend? Good, you picked up your cousin. Okay, from school, yes. Is that all you do? Okay. Good for you, Cody. It's not all about you. All right, here we go. We got 62 miles, but the other part of this question is to find the bearing of the ship from the port. The most important piece to this question is to find the bearing, which is an angle measure. Always start from north. You're going clockwise, and you are from the port. So having said that, we're going to start from the port, which is right here. This is the port. So we're going to start from here. Give me 1 sec. I want to see if this will work. Yes, it did. Okay, so we're from the port. We're going to start here and go all the way. Tell me when to stop. I don't hear you. Now, stop here. That's the angle we're trying to figure out. The whole thing. The whole thing. Do I need to say that again? Anyway, that's 270 degrees. Not the whole thing, but only until this black line here. We need to figure out what this little x is, okay, or p. We're going to call it angle p. Little p, or big P, because we're finding an angle. Well, let's do the law of sines. And here's how I set it up. Sine of 144, that's this 144, that's the 90 and the 54, added together, all over 62. That equals sine of P over 25. Okay? Now, how do you figure out the angle P? Let's figure it out. You're going to cross multiply, and you're going to get angle P is 13.7 or 166.3. Remember, you have to test the reference angles. Make sure you test both values. Don't forget to add it to 270 degrees. Very important. Okay, please take a moment to make sure you can do that. So what did we do with the bearing? Well, we started off by figuring out what is the clockwise angle from north all the way to where you're going to. And in that case, we're going to the ship. Hopefully this example you found helpful. If you are done following along in this example, please make sure your work is neat, and we will move on to example 2. So please exit this video and click example 2. Thank you.